So what we're going to start with is finding the area. Because if you remember when we started this unit, we learned about area. So this one, we're going to be finding composite area, right? Like this is clearly not just one shape that we have here. So we want to split it apart. I'm going to split it apart how I see it first. I encourage you, if you see a different way to do it and you see an easier way to do it or something you would have done, try it and see if you get the same answer as me. Like maybe this is an appropriate time to pause the video and see what happens, right? And then unpause it and work it out with me. So this is how I'm going to split it up. I'm going to call this 1, this 2, and this 3. Number 1 is actually a square, right? I know it's a square because this is labeled as 10 and this is labeled as 10. And then keep in mind, I'm gonna practice showing my work. So to find the area of a square, it's 10 times 10, which is 100 centimeters squared, because I'm not gonna forget units. So I'm gonna go ahead and I'm just gonna underline that so I don't forget about it. Fantastic. And then number 2, the way I labeled number 2, or the way I split it up, it's a trapezoid, right? And what's awesome is, you see this right angle symbol? So that means that this is a right angle. This is a right angle because they're supplementary. They have to add to 180. So this has to be 90. So I know the height, which is fantastic. So now I just have to figure out, do I know the length of both bases? Because if you remember, for a trapezoid, it's base 1 plus base 2 divided by 2 times height. Like you're averaging the two bases and multiplying by the height. Maybe that's something you didn't remember and you do have a formula sheet. Like I encourage you to use the formula sheet. It's also linked. But because you don't have to memorize any formulas, but maybe you saw it as a triangle and a rectangle and you split it up like that. That's fantastic too. Like that will also work if that was where your mind went. So I'm going to use a different color to see if I can figure out these bases. So I know that from here to here is 3. Do I know the rest of this part? In fact, I do. And I do because this whole thing has to be 10. Right? It's a square. I know the side opposite of it. And then from here to here is 5. So what's left over? This part has to be 5. So one of my bases is going to be 3 and 5, which is 8. Right? And then I want to figure out, do I know this one at the bottom? And let's see. So that whole thing across has to be 20. And I knew that from looking down here. So I'm going to go 4 and I'm going to go 2. So I've gone a total of 6. So to figure out this little length, not little, I guess, I'm going to do 20. I'm going to take away the 6 that we've already accounted for. That's going to give me 14. So now I know my two bases. 14 plus 8 divided by 2 times the height, which is the distance between those two bases, the perpendicular distance, so times 4. So that's going to give us 14 plus 8 is 22 divided by 2. So it's 11 times 4 is 44 centimeters squared. So now I've got 2 parts. I'm going to squiggly that with red. For number 3, that's just a rectangle, isn't it? So that's just going to be base times height, or length times width. So 6 times 20, which is going to give me 120 centimeters squared. And then since it's composition, I'm going to do 100 plus 44 plus 120, which is 220, 264 maybe? Yes. 264, and don't forget units, centimeters squared. Right, so to refresh some of our memories on area. What we're going to be doing in this lesson is, as I said, a review, but we're going to apply what we already know about 3D solids to successfully calculate missing measures, right? So not necessarily just the volume. It could be find the radius. It could be find the height, right? And you have to remember that height's always going to be perpendicular to base. I could be asking you to find the area of the base. Or I could be asking you to find the volume, right? Or remember slant height might come in. What did we need for slant height? Oh, Pythagorean theorem. which is a squared plus b squared equals c squared, right? So like this stuff will all come in, as well as finding spheres, right? So prisms, pyramids, and spheres. So before we get into all of that, I want to do a little bit more with area just to make sure that that's fresh on our minds. And then we are going to go through and review all the formulas that we learned about. And again, like use the formula sheet. Okay, so some more finding the area. So again, composition, I'm going to call this 1, this 2. If you want to pause the video and try these on your own to make sure that you're clear, I think that's fantastic. So this is pointing to this. So my triangle, that's going to be, area is going to be base times height, which have to form a right angle, and I see a right angle, divided by 2. So 6 times, well, what is this length? Oh, it's right here. So this is also 8. So 6 times 8 divided by 2. That's 48 divided by 2. So 24 meters squared. And then number 2, 8 times 10, because it's just a rectangle, so 80 meters squared. And then we can add 80 and 24, which gives us 104 meters squared. What about this one? So many ways to split it up. What if we did this? Woo-hoo-hoo. I don't know if this is my ideal way to do it, but I'm going to try this. So this is 15 and this is 10. So like this is 15 millimeters. Yeah. This is 10 millimeters. So that means this little piece has to be 5. So I'm going to split it up. This is going to be 1, this will be 2, and this will be 3. So let's see. This whole thing is 30. This little part is 8, like just from here to here. Whoa, that's terrible. So if I do 30 minus 8, that gives me 22. And then I'm going to have to split it up into 2 parts. So this will be 11 and this will be 11. So to find number 1, I'm going to do 11 times 15, which gives me, oh no, can I do that in my head? 165 millimeters squared. What about here? I'm going to have 8 times 5. I can do that in my head. And then the third one is again 11 times 15, which is 165. So I could have also just multiplied that by 2. So 165 plus 165 plus 40 is going to be 370. Wow. 370, and don't forget your units, millimeters squared. Few more. Here we have a rectangle, and we have a semicircle. So the rectangle, I can just do 8 times 5, which is 40 centimeters squared. And then the semicircle, so if you remember, I'm going to have to do pi r squared, but then I'm going to have to divide it by 2 because it's only half of a circle. So since this whole length is 5, the radius is going to be 2.5 centimeters. Right, so pi times 2.5 squared divided by 2. So what is 2.5 squared is 6.25. Pi divided by 2, which is going to give me 3.125 pi centimeters squared, and I'm going to be adding them. 3.125 pi plus 40 centimeters squared would be a beautiful answer. If you really want to round it, do it in the last step. So 3.125 times pi, please do not use 3.14, use the pi button. And then times plus 40. Remember, order of operations, you're going to have to multiply first. This is approximately 49.817 centimeters square. So if you are going to be rounding, please round to 3 decimal places. All right, so this number 5 over here, I don't feel like this is number 5 though. I feel like this was 3 and this was 4. but I'm not sure. Is that right? Yeah. So number 4, I have a triangle. It's isosceles. Look at that. But I'm told the height of it, so I can treat it as if it's a right triangle, and I have a rectangle. So for number 1, I can do 6, that's the base, that's this, times the height, divided by 2. So that's 18 divided by 2 is 9 centimeters squared. And then for number 2, I can just do 5 times 6, which is 30 centimeters squared. And 30 plus 9, oh, I can do that. 39 centimeters squared. Fantastic. So this is our last one we're going to look at with kind of an application here. So here's a diagram of the track Kings is thinking of adding around the new field. The wording is very bizarre, sorry. It consists of 2 parallel lines and a semicircle at each end, okay? So if you kind of think about, and I'm going to draw these lines down here. I've got a rectangle in that middle and 2 semicircles, right? That's what this track is kind of formed by. The track is 10 meters wide, so like this distance is 10 meters. Okay, so if someone runs 1 lap on the outside, how far will they run? I'm sorry, on the inside, I was ahead of myself. How far will they run? So we're trying to look at the distance around. This is a little bit different. So we haven't totally done something like this. This is an extension, but this is a fun problem to try. So we probably know this length, from here to here and from here to here. Right? So we know that this is 100 and this is 100. We just need to now figure out, well, what is this distance? Which is going to be the same as this distance. You guys know area. This is perimeter. This question is a perimeter question, which we haven't done as much with. But if you remember, so perimeter for a circle is called the circumference. Okay, and so to find the circumference of a circle, it's pi times diameter, which is the same thing as 2 pi r. So if I'm trying to find the distance around it. Okay, so I can find it and divide it by 2 or not because I need both of them, right? So what is the radius of this circle? Well, if the whole way across is 64, the radius would be 32. I really didn't need that, but that is good for us to know as well, right? So we're going to have 2 pi r is going to be 2 pi times times 32, which is going to give us 64 pi. That's going to give you the entire, like both semicircles, right? If I divide it by 2, then I'd have 1 semicircle. So I really just need to do 100 plus 100 plus 64 pi. It's going to give me 200 plus 64 pi meters. And it's not squared, it's just a length, it's a distance. What about if somebody runs on the outside? Okay, so it's still 100 and 100. So like this is still 100. Sorry, that was messy. And this is still 100. Oh, there you go. But what about, I need a new color, this distance? What happens here? What is the diameter? What's the radius there, right? So I know from here to here is 32, and I'm going 10 further. So my radius is 42. Right, so now I'm going to do, well, 2 pi times 42, which is going to give me 84 pi, and that will account for both halves. And then I can do 84 pi plus 100 plus 100, and I'm going to get 200 plus 84 pi meters. What about find the difference between the distances run if you're doing the outside track versus the inside track? The outside of the track versus the inside of the track. So I'm going to do the bigger one, 200 plus 84 pi. I don't even need the decimal. Minus 200 plus 64 pi. 200 minus 200, those will go away. So I'm going to have 84 pi minus 64 pi. Oh, they're like terms. So 20 pi meters. If you really want to multiply by pi, go for it. But think about how I didn't even need a calculator for this, right? So this is a little bit different. It's still the idea of composition, but it's kind of like a different track of it that hopefully is somewhat interesting to you guys. Fantastic. So what we're going to look at now, we're going to transition to reviewing now, is actual volume. Now that we've kind of solidified our understanding of area, hopefully, we want to look at volume. So what is volume? Well, volume is the amount of space that something takes up, right? So think about like how much water you can fit in an object. Like that is the volume. Like how much can something hold is the volume of it. So we had some formulas. And again, these are on your formula sheet, but let's review the formulas. So the volume of a prism, right? So where B is the area of the base. So a big piece of this is, right? And height is I'm going to do perpendicular. That's what that symbol means. It's the perpendicular distance between your bases. Right? So a prism, you have two bases that are, I'm going to use some symbols here. Sorry, guys. Two bases that are parallel and congruent. So it's the volume is the area of the base times the height. So you have to identify, well, what is the base? Like, what do I have two of that are parallel and congruent to each other? And start with that, and then you're thinking, well, for a prism, it's like you're taking a 2D shape and moving it into the 3D. So it's like, how many of them am I stacking on top of each other? That's the height, right? So that's why it's the perpendicular distance, because you're directly stacking them. I put cylinder underneath this because I've always treated cylinders like they are prisms, like they operate the same way. But I mean, it's still area of the base times height, but the base is a circle, so it ends up being pi r squared times height. But if you just think about it as a prism, you're good, right? Like we don't have a specific formula for a triangular prism, even though it's 1/2 base times height times the height of the prism. Right, so I always have just grouped it with the one above, and I believe your formula sheet does as well, and it might give this more specific one, but if you just think about it as a prism, like you're thinking about three shapes. For a pyramid has one base, and the height is from the apex perpendicular to the base. You guys have learned about oblique and right, and if it's right, then the apex would be directly above the center of the base, whereas if it's oblique, it's kind of going to be leaning, which we're going to come back to in a later topic, in a later video. So for a pyramid, well, if I have a pyramid and a prism with the same base and the same height, 3 of the pyramids will fit into that prism, right? So volume of a prism is area of the base times the height divided by 3, where B is still the area of the base, and H is still the perpendicular distance but now it's from the apex, kind of like the vertex. It's like the top point, apex to the base. There's only going to be one base for a pyramid. I don't know why I wrote 2. One base. A cone, again, like I group it is a pyramid. It's like a type of pyramid. It's still going to be area of the base times height divided by 3. But you can think about it as, it's pi r squared times height divided by 3 if you want to go more specific with it. Fantastic. And then sphere. A sphere only has one dimension. Should I try to draw one? Nobody's there to tell me not to. That looks like a circle. I have to do something like this. Oof. Oh, that wasn't bad, right? So it just says the radius is really the only dimension of a sphere. It is the only dimension of a sphere. So the volume of a sphere is going to be 4/3 pi r cubed. Which related to, there was a school yourself video that I believe you guys did where it related to prism and pyramid, but more like with cone and cylinder. It's like the space that's left over from when you put a cone inside of a cylinder. I believe that's what that video had talked about. And if you want to go back and watch it, there is like, if you want to see that school yourself video, it is pretty, it's a lot of information that you don't necessarily directly need, but those of you that want a full understanding of how these all relate, it's a great way to do it. So school yourself on cones. Awesome. So all of this stuff on your formula sheet doesn't have to be memorized. I just wanted to review and talk about what each piece of it means. And we are going to do some practice. So when we're doing these, how I like to approach it is let's name what these are so that we're starting off with that. Like, are you appropriately identifying what type of figure or solid this is? I won't ask this on every question, but I will continue to do it because it's how I work best. And I think that's a great way to approach it. So this right here, well, it's going to be named by its base. Right, so there's a rectangle. So this would be a rectangular. And it's going to be a pyramid. Or it is a pyramid. Right, this is the apex, if you're not sure what I mean by apex. I can see that this is perpendicular to the base. So if I'm going to find the volume, it's going to be area of the base times height divided by 3. The area of the base, well, it's named by it. It's a rectangle. So I've got to do 5 times 10, which is 50. So that's the area of the base. The height is 5, right? It's the distance from the apex perpendicular to the base. So to find the volume, I'm going to do 50 times 5 divided by 3. So let's see, what is that? 50 times 5 divided by 3 gives me a nice decimal. So I'm going to leave it, instead of rounding a decimal, let's just leave it exact, 250 thirds. And my units are inches, and now we're talking about 3D, so cubed. What is this? This is a sphere. Ooh, wow, that is absolutely not how you spell sphere. Right, so sphere, the volume is 4/3 pi r cubed, right? R cubed is r times r times r. So the volume is 4/3 pi, I see the radius, 7 cubed. So 7 cubed is 7 times 7 times 7, which is 343. So I'm going to do it in pieces just so that you guys, especially those of us that don't totally remember this, are getting a full visual of it. So what I'm going to do to multiply this out is I'm going to multiply 4 times 343 and then divide by 3, right? Especially if you have a calculator. So 4 times 343 and then divided by 3, it gives me a decimal. I'm not going to round it, so I'm going to leave it as a fraction. 4 times 343 is 1372 over 3. Pi, I'm going to leave it in terms of pi, centimeters cubed. This last one, well, it's a pyramid, right? I see the apex. And if you're looking at the base, ooh, this is a great one. It's a triangle, right? I see a triangle. It's actually an equilateral triangle, right? All the sides are marked as being congruent. So they're all 6. Huh. So this is going to be or not this is going to be, this is a triangular pyramid. So volume is going to be area of the base times height divided by 3. So for something like this, though, I need to figure out what the area of the base is. Well, it's a triangle. I don't know what the height is. I know all the sides are 6. We said it was equilateral, so what does that mean all the angles are in the base? 60. So this is a non-right triangle, so why don't I just say 1/2 AB sine C? Don't forget that you should be in degree mode because we're using trig. Oh no, I want this color again. So it's going to be 1/2. The two sides are going to be 6 times 6 times the sine of 60, the angle between them. So the area of the base, I'm in degree mode, 1/2 6 times 6 times the sine of 60. And I'm gonna have to round this right now, right? So I'll round it to 3 decimal places, and this is the point where I'll round 588. Yeah, and if you want to write more, that's fine. I'm gonna make it clear that this is where I'm rounding. In fact, if you really didn't want to round, this is actually a great skill, like as you're moving forward. If you see that button in your calculator that says STO, it's right before where it says LN, it's right above where it says on. You could push right now that it's already in your calculator. And those of you that are like, oh, but I don't have a graphing calculator, I did send out an application for you to download it onto your computers. And it's free through TI. So I think that's a great thing for you guys to use. It's also linked on the resources if you don't remember where that email was, as is one that you could download from a Chromebook. So if you want to experience this, especially those of you that are thinking forward to Algebra 2 and pre-calculus and beyond, this is great. So this is going to stop me from rounding. I'm going to do STO, and it's going to pop up, and it'll say A and S, and then give you a little arrow. And I'm going to push second. Oh, no, I'm not going to push second. Don't do that. I'm going to push alpha. I'm staring at it, and I pushed the wrong thing. I'm going to push alpha, that green button, or the button that's right below second. And you could pick whatever letter you would like to call it. So I'll push alpha A, which is like alpha math. And I can actually show you guys this, but I don't think I have the setting on my computer for me to be able to show it to you. So it'll store, and then it will store it. And anytime you push alpha A, it'll recall it. Like you could right now push alpha A, enter, and it's going to tell you 15.588. So it's now stored in your calculator. If that doesn't work for you, it's fine. It's just an interesting thing that you can do with the graphing calculators, especially that you all generally have access to them now with the free download. So that's the area of the base. What about the height? The height. So to find the height, so I don't know the height. I know that this is 30. I'm sorry, I know that this is 10, but I don't actually know the height, do I? Oh, I don't like this problem. We're going to pretend that that's the height, because technically you'd have to use Pythagorean theorem, but I don't like it. We're going to pretend that that 10 goes to there. So ignore my work there. So just pretend. We're going to pretend that the height is 10 centimeters, and we're going to do 15.588 times 10. And I'm going to get 155.88 centimeters cubed. If you were somebody that stored it in your calculator, what you're going to do to find the volume is you're going to push alpha math and then times 10. So alpha math times 10, and it's going to give you, alpha math times 10. It's going to be like basically the same thing, but you could round it a little bit different now, 155.88 5 centimeters cubed is probably what you would say, rounding to 3 decimal places. So again, ignore the fact that I had that 10 out there. I want that 10 to be the height. It was indicated as the slant height, but that's not what I had intended. Awesome. Okay. So let's do some more practice. Some more. Let's keep going. What color do I want? This color. So here I'm giving you the volume. And I'm asking you to find the radius, right? So you're working backwards a little bit. So, well, this is a cylinder. It behaves just like a prism. So to find the volume, it's area of the base times height. For the area of the base, I don't know it, but I do know that it's pi r squared because it's a circle. For the height, I do know it, it's 4. And I actually know what the volume is. So what I could do is I could say, well, you've got 100 pi equals the area of the base times 4. And let's solve for the area of the base. Divide by 4, and that's going to give us 25 pi equals the area of the base. Okay, and my goal is to find the radius, so don't forget that. So area of the base, 25 pi, is going to equal to pi r squared. If I'm going to go about solving this, I can divide by pi, and it's going to cancel. So then that's going to give us, well, 25 is the radius squared. So if I take the square root of both sides, 5 is the radius. So your radius is 5 units. Awesome. Here I'm asking you to find the volume. So this is where I actually want it. So this 5 is called, the slant height. So I don't have the height here. I'm going to solve for it. This is a pyramid, right? It's a square pyramid because the base is a square. So volume is area of the base times height divided by 3. The base is a square, so 6 times 6, so it's going to be 36. The height I don't know. I've got to actually solve for the height. I have to figure that out. But what I do know is I do know that this is 5. I know that this distance is going to be 3 because that's going to the center of the base. So what shape do you have right here? A right triangle. So you can use Pythagorean theorem. So for Pythagorean theorem there, I can do, well, the height squared, plus 3 squared equals to 5 squared. The height squared plus 9 equals 25. Right? Remember the hypotenuse, the side across from the right angle, is always c. A squared plus b squared equals c squared, and the legs are interchangeable. So the height squared is going to equal to 25 minus 9, so 16. When you square root, you're going to get that the height is 4. Right? So now I know the height. So then I can say, well, the volume is going to be 36 times 4 divided by 3. 36 times 4 divided by 3 is 48. So it's going to be 48 units cubed. We're getting a variety of different practice here, is what the goal is. Okay, so let's do some more. What shape is this? Notice it's not accurately drawn. It's not going to be drawn to scale. Okay, so there's no apex. what is congruent and parallel? Oh, this right here, right? I think the thing that's closest to me is the base. Right, I think this thing is the base, right? They're parallel and congruent. So this is gonna be, this is a fun word to say, trapezoidal prism. Okay, so it's a prism, so area of the base times height. So then we have to figure out, well, what is the base? What is the area of the base? So a trapezoid, you're going to do base 1 plus base 2. Remember, average the bases and divided by average the bases times the height. So notice I'm just going to focus in what I just highlighted. Like, that's it. So this is great because I know that these are perpendicular. So the two bases are going to be 1.7 plus, but what is this length? Oh, it's back here. It's on the other one. 2.3 divided by 2 times 1.3. Like, notice I'm not leaving the base. This 1.5 is not what I'm looking at. So 1.7 plus 2.3 divided by 2 times 1.3 is going to give me 2.6. So the area of the base is 2.6 meters squared. The height of the prism is going to be the distance between the two bases. So here is going to be the height. So 1.5 meters is going to be the height. So then I'm just doing 2.6 times 1.5 which is going to be 3.9 meters cubed. What about this? Oh, it's another one. It's another trapezoidal prism. So again, volume's going to be area of the base times the height. The base is a trapezoid. Base 1 plus base 2 divided by 2 times height. I'm going to highlight it again. So here, so even though it's not on the bottom, if you tried to look at what was on the bottom, it's not congruent to what's on the top. This base, though, there's going to be one here and one on the other side. That's, even though it's on it, it's not, so it's not sitting on its base. So you got 8 plus 6 divided by 2 times the height of it, the distance between those two bases. That's 14 divided by 2 times 5. That's 7 times 5. So 35 centimeters squared. And then think about, well, what is the height? The distance between the two bases, 20. If you looked it up here, oh, that's also 20, right? So this is going to be the height. So the height is going to be 20 centimeters. So to find the volume, you're going to do 35 times 20. Is that 700? Yes. 700, and don't forget units, centimeters cubed. A few more, we're going to finish up. What shape is this? If you haven't tried it on your own, like, please pause the video and try it on your own. Test yourself right now, right? So here, we're going to have a triangular prism, right? There's two bases. Here's my base. There's one over here that's parallel and congruent to it. So that means that this right here, this 7, is going to be the height of the prism. It's the distance between the two bases. It's like how many triangles are you putting next to each other is what the height is really indicating. So the volume is going to equal area of the base times the height. The area of the base, darn, it doesn't say it's perpendicular, so I'm just going to tell you that it is. 4 times 3 divided by 2, because a triangle is 1/2 base times height. That's 12 divided by 2. So 6 centimeters squared is the area of the base, and the height is 7 centimeters. So the volume is going to be 6 times 7 which is 42 centimeters cubed, right? Because you're multiplying centimeters squared times centimeters. So it takes it into the third degree. Again, if we haven't tried one, please, please, please try it. Also, this is a great one. A triangular prism. So volume's an equal area of the base times the height. Area of the base, 1/2 base times height. Remember, base and height have to be perpendicular. So here's my base. Ooh, here's also my base. And then this right here, this is my height because that's the distance between my bases. So I actually don't have the height of this base, right? That I've got to use Pythagorean theorem again. Height squared plus 15 squared equals 17 squared. Right angle, go across from it. That has to be C in the Pythagorean theorem. That's your hypotenuse. So h squared plus 225 equals 289. When you subtract 225 from both sides, you get 25, I believe. 289, no you don't. You get 64, sorry. So when we do the square root, we get that the height is 8. So the area of the base is then going to be 15 times 8 divided by 2. It's like 15 times 4, which is 60. So the area is going to be 16 centimeters squared, and the height we knew was going to be 10. That's over here. So the volume is going to be 10. No, what's the area of the base? 60 times 10, which will be 600 centimeters squared. All right. Oh, I'm like all off. We've got 2 more. This is 9, and then we've got 10, I believe. So for this one, it's a little bit more of an application here. Given that the cylinders below, typo, have the same volume, calculate the missing height, right? So I know everything for this. I'm missing the height over here, the distance between the bases. So I want to figure out the volume of this, right? So it's a cylinder, so it's going to be area of the base times height, pi r squared. Pi times 4 squared. So 16 pi is the area of the base. So you're going to do 16 pi times 10. Notice I'm not multiplying by pi. 160 pi centimeters cubed is the volume. Well, this is going to have the same volume. That's what it told me, right? So volume is still going to be area of the base times height. I can figure out the area of the base, right? I know the radius. Pi times 2.5 squared. Is that 6.25 pi? I'll check my own work. Yes, 6.25 squared. I'm sorry, 6.25 pi centimeters squared is going to be the area of the base. I don't know the height, though. That's what I'm missing. So I know the volume is 160 pi. I know the area of the base is 6.25 pi, but I don't know the height. So maybe we recognize why I left the pi. Well, if you divide both sides by pi right now, it's going to cancel. And then you're not dealing with an irrational number or something you rounded and it's causing error. And then to find height, it's just divide by 6.25. I do it in parts to avoid any error, because if you don't correctly group things in your calculator, it's not, your calculator can do order of operations, and then it's going to divide it by 6.25 and multiply it by pi. So if you just do it in parts, it's going to avoid that error that you might have from entering it incorrectly. So that we get the height is 25.6, and what's the unit? Centimeters is the missing height. Right, so this right here, this height would be 25.6 centimeters. Fantastic. Okay, so the final one, I did a composite volume, right? Like it's multiple shapes together, multiple solids. So I'm gonna kind of like how, we started with a composite area one, so now it's taken it into 3D, and let's finish up with a composite volume. So if I were to like slice the solid down here, I would get a rectangular prism and another rectangular prism, which we know how to work with. So this rectangular prism, I'm gonna look at some lengths here. What is this length right here? Well, the whole thing is 7. This little piece is 2. So this has to be 5. Right? I know this is 4. What's the third distance here? Well, it's 10, 10, 10. Oh, it's got to be 10. So the volume of, for number 1, if we do area of the base times height, I'm going to have 5 times 4. The distance between those two is times 10. It does not matter which one you call the base for a rectangular prism, because you end up just multiplying the 3 dimensions. So that gives us 200, right? 20 times 10 centimeters cubed. So then I've done this one. I've done number 1. Number 2, also area of the base times height. So I've got, let's do a new color. I know this is 2. I know this is 9. Oh, and I know this is 10. So let's say I called this one over here the base. I could say 9 times 2 times 10. So that's going to give me 18 times 10, so 180 centimeters cubed. Is that right? Yeah. And then I can do 200 plus 180. It's going to be 380 centimeters cubed. I would be curious if I just had put this question out there, if anyone would have come up with a different way to do it, right? Like in all reality, based off of what we've done and even how we started this, what if we had just found the area of this and then multiplied it by the height, right? Like you can find the area of that whole base, and we could have said, well, this is 20 and this is 18. So why don't we just do 38, right? 20 and 18 times height. Like we know that there's 2 of them and they're congruent. Like this is like a composite prism is really what's happening here. So I didn't have to break it up into 1 and 2. I could have just found the area of this whole base in any way I wanted. And I could have broken it up differently. Like maybe I would have said this rectangle and this rectangle. It didn't have to be this exact way. That's still going to give me 380 centimeters cubed. Right? It's just a different way of thinking about it. Fantastic. So what we did in this lesson was we did a ton of review, right? So we started off and we looked at area and composite area. We reviewed the formulas for finding volume, and then we did a variety of problems incorporating volume of prisms, pyramids, and spheres, which included cylinders and cones. I encourage you guys to use the extra practice resource and the activities that are posted to help you to solidify your understanding of this. But again, this was a lesson that you had done in class. I just wanted to provide you some review and extra support with it. If you have questions, of course, please feel free to reach out to any of the teachers and post questions, and we would be happy to help. So thanks, guys.